Hey guys, how's it going? So I got my iPad on January 14, few weeks ago, and it's pretty good. I got the XP Pen. What was that? I think it was let me see. It was XP Pen W. No, it was Deco One V2. I highly recommend it. It's like really good. I might do a review just on this in a few videos to come. Before I go over today's lesson, let me just show you. It's like it basically you can draw anywhere you like, and like and it doesn't do any, and it doesn't even scratch your screen. It's like legit so good. Um, and it's like so much faster than before when I like kept having to write when I kept having to write like something like um this like x squared, like this was so slow, and then I could just say x squared like that. It's like just so much faster. I spent a bit of time getting used to the stability and balance of this. In my future videos I'm going to be using this. It's a little sloppy at first when I did it. I'm going to have to get used to it. The disadvantage with it is like you can't look at your pad while you are writing, but it's just something you get used to. So yeah, I think yeah, let's just try it for this video. So let me just clear everything. Okay, so now on to today's video. So what if I told you you can solve an integral without doing any integration at all? This is a question I found that Chinese students were often given in order to have the Wi-Fi access to their school, basically. So it went something like this. The integral from 2 to -2 of, what was it, x cubed cosine of x squared plus 1 over 2 x over, wait, cosine of x over 2, yeah, x over 2 plus 1/2. Okay, and then times the square root of 4 minus x squared dx. Okay, and apparently the code, the answer, the first 10 digits of the answer was the code, apparently. So you could just imagine a bunch of kids grabbing their phones out saying, oh, I'm just going to Google this answer. And they're like, oops, no battery. Ah, shit. You know, it's like something like that. But yeah, I remember a Calc 2 prof, not mine, but some prof gave this as a bonus question. And apparently the kids only had 5 to 10 minutes to do it. A lot of them didn't finish this question because they were like struggling. They were doing trigonometric substitution. I was looking at this and I'm like, by a stroke of luck, I was able to do it in 3 minutes. So let's get along with it. So the first thing I'm going to do is I'm going to distribute this out, basically. So I'm going to say that this is equal to, and and I'm going to separate. So I'm going to say this is from -2 to 2, x cubed cos of x over 2, root 4 minus x squared dx. Just distributing it out right now, plus, and then plus, okay, so then from -2 to 2, 1 over 2 root 4 minus x squared dx. Okay, now have a look here. We are basically done. We don't do any more integration. Look from here, okay? I used my mouse, old habits. I'm going to do an observation. X cubed is an odd function. Okay, that's the first note. Cos of x over 2 is an even function. And root 4 minus x squared is also an even function. Okay. There's a principle that I learned myself without like going to the prof, because I took business calculus, so which is easier than regular calculus, but I learned myself. And here are the 4 rules. Let me write it down here. An odd function times an odd function gives you an even function. Okay, an even function times an even function gives you an even function. However, if you have an odd, times an even, or an even times an odd, then that gives you an odd function. So let's apply that here. And I'm going to explain to you really quickly why this will be useful. So 2 negative 2 x cubed, let's rewrite this, cos of x over 2, 4 minus x squared dx. Okay, so odd times even is odd. And then this times an even, the result is an odd function. So let me just say that this is an odd function. Okay, and the answer to this integral is 0. And let me explain why. When you have an integral, okay, when you're integrating an odd function, like, let me draw something like this. This function is roughly x cubed. Okay, and let's say this is negative 1. Let's say this is 1. Let's draw our typical x and y. Okay, when you have an odd function, that's like, let me save this, a negative a, f of x dx. F of x, if f of x is odd, then the I Sensor value of integral is basically 0, assuming a is a real number. It's perfectly symmetrical. Take, for example, y equals x cubed, right? There's like there's equal area from -1 to 0 and from 0 to 1. So then the integral of x cubed from -1 to 1 is 0. You could do the antiderivative and figure it out there, but you could just do this by eye and see this like, oh yeah. So here you have an odd function. It's from -2 to 2. So that's actually just equal to 0. So this part is done. Now, from 2 to -2, let's figure this out. Let's do 1 over 2 and then move that out. 4 minus x squared dx. You could do the integral, find the antiderivative, but really you only have like 10 minutes. This is like a fire drill. You better get out as fast as you can. This integral is actually asking you to find the area of a semicircle. It looks something like this. So look here. -2, 0, 2, x, y. Okay. Root 4 minus x squared. That's like the same thing as x squared plus y squared is 4, but it's just the top half. What is the area of a circle? A is pi r squared, right? But like it's only the top half of the semicircle. So in this case, it's over 2. The radius is 2, so it's 2 pi. So that's the answer to the integral from 2 to -2 of root 4 minus x squared dx. So then this is equal to 1 over 2 times 2 pi, and that's equal to pi. So from here, our answer is just pi. Because get it, this value, the value of this integral is 0, and the value of this integral is just pi. And the first 10 digits, that is 3.141592654. And now you are done. You can go have Wi-Fi. Go watch Hopeless Romantics and hope you can get a girlfriend like me. I'm not the girlfriend, just speaking, just to clarify. All right, so that is all for today's video. I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.